Hello students, we will do one more example and I will give you a problem for doing homework also on triple integrals in spherical coordinates. Okay, so first take the homework, evaluate triple integral 0 to pi, 0 to 2 sine phi, rho square sine phi, d rho d phi d theta. So rho square sine phi d rho d phi d theta is dV, the elementary volume, and so therefore the integrand here is again identically equal to 1. The integration is first with respect to rho, so rho varies from 0 to 2 sine phi, then with respect to phi varies from 0 to pi, and with respect to theta, theta varies from 0 to pi. So take this as homework, and we will consider another example, and it's a part we shall do here. So let D be the region bounded below by the plane z equal to 0. Z equal to 0 means the xy plane, above by the sphere x square plus y square plus z square equal to 4. So means you have a sphere centered at the origin and radius equal to 2, and on the sides by the cylinder x square plus y square is equal to 1. So this cylinder has axis as the z axis, and radius is equal to 1, and you are asked to set up triple integrals in spherical coordinates that give the volume of D using the following orders of integration. So this is the first problem. So integration with respect to rho first, integration with respect to phi second, and integration with respect to theta last. And you are asked to set up the triple integral. You are not asked to evaluate the triple integral. If you are asked to evaluate the triple integral, you have to evaluate also. So let us plot the region D first. So first draw the xyz axis. So this is the x-axis, this is the y-axis, this is the z-axis, here is the origin O, and now you draw z equal to 0, that means the xy plane. So the region is bounded below by z equal to 0, so the xy plane. Then on the upper side by x square plus y square plus z square is equal to 4, that means it is a sphere of radius 2. So this is that sphere of radius 2, and on the sides by the cylinder x square plus y square is equal to 1. So this is the cylinder x square plus y square equal to 1. Axis of the cylinder is the z axis, and on the sides by the cylinder. Okay. Now to set up the limits for triple integral or iterated integrals, what you have to do first is draw a ray that starts at the origin and pass through this region D. So where it enters the region is the lower limit of integration, and where it leaves the region is the upper limit of integration. So let us draw that line first. So I can draw a line like this. This is my M, or I can draw a line like this. Oh no. Okay. or I can even draw like this. Yes. So let me again redraw. So I can draw ray like this. This is my M. So if this is my M, the second one which I drawn, then it enters the region D when rho equal to 0 and leaves the region D at this surface. X square plus y square plus z square is equal to 4. That means rho equal to 2, right? But if M is like this, then M enters the region when rho equal to 0 and M leaves the region when x square plus y square equal to 1. So it's a different upper bound. So what you have to do is, in this case, you have to split the region into two subregions, D1 and D2. So let us say D1 and D2. This portion is D1 and the lower portion is D2. And in D1, the ray enters the region when rho equal to 0 and leaves the region when rho equal to 2, because the surface is given by rho equal to 2. X square or equivalent x square plus y square plus z square is equal to 4. Rho square equal to 4 or rho equal to 2. Okay, and in D2, lower limit is 0 for rho, but the upper limit is different. We have to find it out. And then we use what is called the additivity property of the triple integral. So triple integral over D dV equal to triple integral over D1 dV plus triple integral over D2 dV. This is what? Okay. Now for D1, rho varies from where to where? We have discussed 0 less than or equal to rho less than or equal to 2. And now we have to find out the limits for phi. The next variable is phi. For part A, next variable is phi. So phi varies from where to where, that we have to determine. So phi varies from, so this is phi equal to 0, and phi can vary from 0 to this angle. So we have to determine what is this angle. So phi min is 0 and phi max is this angle. So what is this angle? So we have to know what is this point. So to know what is this point, you have to solve the equations x square plus y square plus z square is equal to 4 and x square plus y square equal to 1 simultaneously, because that is the intersection of those two surfaces. Okay, so let us solve. So let us solve these two simultaneously. Which two? This and these two equations simultaneously. So substitute for x square plus y square equal to 1 in the second equation, namely this. So you will get 1 plus z square equal to 4 plus z square equal to 4. So z square equal to 3 or z is equal to root 3. There is no minus root 3 because minus root 3 is below the plane z is equal to 0. So this point is precisely x comma y comma root 3. This point is precisely x comma y comma root 3. This point is x comma y comma root 3. Right. This point. Now look at the projection of the line M to the shadow region. So what is this point? It will be x comma y comma 0. X comma y comma 0. That is the projection of this point. So what is this height? This height is precisely root 3. Okay. So here z varies from 0 to root 3. Here z varies from 0 to root 3. So now what is this angle? Phi, that we have to determine. So phi varies from 0 to what is the upper limit? So it will be better to take tan. So tan of this angle is equal to root 3 divided by no. So what is this angle?